Today we will resolve some vector in different directions. For example, this is a vector A and this is vector B, and we want to resolve this vector OP in the direction of A and B. For this, we will draw a straight line starting from O and of course parallel to A, and again we draw a straight line from P which is parallel to B, and the point of intersection of these two lines is of course Q. Now OQ is vector A multiplied by some scalar quantity lambda, and QP is vector B multiplied by some scalar quantity mu. So from vector law we can write OQ plus QP is equal to OP. So OP is OQ lambda A plus QP is mu B. Now we have resolved OP in the direction of A and B, and this is the component of OP in the direction of A, lambda, and the component of OP in the direction of B is mu. We can resolve a vector A of course in three mutual directions as AXI plus AYJ plus AZK, where I, J, K are unit vector in the direction of x-axis, y-axis and z-axis, and AX is the component of vector A towards x-axis, AY is the component of vector A towards y-axis, and AZ is component of vector A towards z-axis. Now we will resolve the vector R in only two mutually perpendicular directions, and later on we will resolve the vector R in three mutually perpendicular directions. So this is vector R. Say this vector R is of 10 unit, and we want to resolve this R in two mutually perpendicular directions, that is x and y axes. If R makes an angle theta with x axis, then we draw a perpendicular from R to the x axis and again from R to the y axis. This is your 10 unit. R is 10. So this is your A and this is your B. Now cos theta is OA divided by R, that is OA divided by 10, and sin theta is OB divided by R and OB divided by 10. So now OA, which is Rx, the x component of R, Rx is the x component of R, and it can be written as Rx divided by R is cos theta, and this is your Ry. So Ry divided by R is sin theta. So R can be written as, this is Rx and this is Ry. So we can write R as Rxi plus Ryj. This is the x component of R and this is the y component of R. The magnitude of R or the mod of R can be written as Rx square plus Ry square root under. And the angle made by the R with x axis, it can be written as tan theta is Ry by Rx. Now we can resolve any vector in the x and y direction. For example, this is vector R. It is of magnitude 10 unit and it makes an angle of 37 degree. Now we want to calculate the x and y component of vector R. So Rx is R cos theta, that is 10 cos 37. Tan cos 37 and cos 37 is 4 upon 5, so it is 8 unit. And Ry is of course R sin theta, that is 10, and sin 37 is 10 3 by 5, that is 6. So now R can be written as Rxi plus Ryj, and Rx is 8i plus 6j. Now of course the angle is in the first quadrant. If the R makes an angle which lies in the second quadrant, for example, we want to resolve vector R of course in x and y direction. This is our x axis and this is our y axis, and the angle is of course 120 degree, and we want to calculate the x and y component of the vector. Now this of course R is x unit. Rx is R cos 120. This 120 is of course 60 degree in the second quadrant, and in the second quadrant cos theta is negative and sin theta is positive. So it is 10 and cos 60 is half with a minus sign, so it is 5. And Ry is R sin 120. This 120 is 60 in second quadrant. 60 in second quadrant. It is 60 in second quadrant, and of course it is 10 and sin 60 is root 3 by 2. So R is of course Rxi plus Ryj. This is minus 5i plus 5 root 3j. So now we can resolve any vector making any angle with x-axis. For example, if the angle lies in the third quadrant, or of course in the fourth quadrant, we can resolve the vector into of course x and y direction. So now if the vector is like that, this is vector r and the angle is 240 and r is 10 unit, and again we want to calculate the x and y component of vector r. So now Rx is r cos 240, that is 10 cos 60, and this in third quadrant. This is in third quadrant. 240 is 60 degree in third quadrant, and in third quadrant both sine and cosine are negative. So it is 10 and that is half, so it is -5, and Ry is r sine 240, so it is 10 and sine 60 in third quadrant, and it is 10 root 3 by 2 with a minus sign, so it is 5 root 3. So now this r can be written as -5i minus 5 root 3j. Similarly, if we want to resolve this vector r of magnitude 10 unit and the angle is 300, r makes an angle of 300 with x-axis. This 300 is basically 60 in the fourth quadrant, and in the fourth quadrant cos is positive and sine is negative. So Rx is r cos 300 and that is 10, cos is positive half, that is 5, and Ry is r sine 300, that is 10 and it is minus root 3 by 2, so it is minus 5 root 3. So r is Rxi plus Ryj. So r is 5i minus 5 root 3j. So we can resolve any vector making any angle with x and y axes. So now what is the use of this resolution? Why we have resolved this vector r in x, y component? Of course in the 2 dimension only, the third dimension has not been used here. So you may ask, what is the use? मैंने इसको क्यों रिजॉल्व किया, पर्पस क्या है रिजॉल्व करने का? तो रिजॉल्व करने का पर्पस ये है कि इफ वी वांट टू ऐड लार्ज नंबर ऑफ वेक्टर्स एक्टिंग इन द सेम प्लेन, बहुत सारे वेक्टर्स को जो एक प्लेन में काम कर रहे हैं, हम लोग उसको जोड़ना चाहते हैं, ऐड करना चाहते हैं, तो हम लोग सुपरपोजिशन प्रिंसिपल को अप्लाई करेंगे. According to superposition principle, if large number of vectors are acting at a particular point, the behavior of one vector is independent of the presence of other. This is the point. Here, large number of vectors are acting. This is x-axis, this is y-axis, this is vector r1 making an angle theta1 with x-axis. Vector r2 makes an angle theta2 with x-axis. This r3 makes an angle theta 3 with x-axis, and similarly vector Rn makes an angle theta n with x-axis, and we want to add all these vectors. So now, according to superposition principle, if large number of vectors are acting at a particular point, one vector behave as if all other vectors are absent. So we simply resolve all the vectors in x and y component. All the x component are added. This will give the x component of the resultant vector, and all the y component of individual vector are added, and it will give the y component of resultant vector, and hence the resultant vector can be of course obtained by taking the mod of these all addition, and of course the angle also can be calculated. For example, your vector r1 can be written as r1 cos theta I1 plus r1 sin theta j. Similarly, r2 can be written as r2 cos theta 2i plus r2 sin theta 2j, and r3 cos theta 3 plus r3 sin theta j, and Rn can be written as Rn cos theta ni plus Rn sin theta nj. And if all the vectors are added, so the resultant R can be written as R1 plus R2 plus Rn, and it is R1 cos theta 1 R2 cos theta 2 plus Rn cos theta n I plus R1 sin theta 1 plus R2 sin theta 2 plus Rn sin theta n j. If all these components are added, it will give Rxi, and that will give Ryj, and the magnitude of vector R is Rx square plus Ry square root under, and the angle made by the vector is Ry by Rx. So we can resolve and also add any number of vectors. For example, if it is given that there are 6 vectors, each of magnitude 10 unit, making an angle of 0 degree, 60 degree, 120 degree, 180 degree, 240 and 300. What is the resultant of all these vectors? So we are going to add 6 vectors, each of magnitude 10 unit. So there are 6 vectors. This vector of 10 unit makes an angle of 0 degree, this with 60 degree, this of course 120 degree, this 180 degree, this 240, this 300, each of magnitude 10 unit. So what is the resultant? This is 60, this is 120, this is 180, this is 240, this is 300, and we are going to calculate the resultant of all these vectors. Now the first vector R1 is R1 cos 0i plus R1 sin 0j. The second vector, again it is also of same magnitude, so R2 is R2 cos 60 and R2 sin 60j. R3 is R3 cos 120i plus R3 is sin 120j. R4 is R4 cos 180i plus R4 sin 180j. R5 is R5 cos 240i plus R5 sin 240j, and R6 is R6 cos 300i plus R6 sin 300j. Now each vector has magnitude 10 unit, so now it can be written as 10i plus 0j. 10 cos 60 is half, 10 root 3 by 2j. 120, it is 60, so it is 10 by 2i and plus 10 root 3j. Again minus 10i plus 0j, and 240 is in the third coordinate where both are negative, so it is minus 10 half plus minus 10 root 3 by 2, and in the fourth quadrant it is positive 10 half and of course minus 10 root 3 by 2. If we add, this is of course cancel, again this will cancel, and again this will cancel this. Now this is cancelled by this, this cancelled by this, and the resultant is 0i plus 0j. So the resultant is 0i plus 0j, that is r is 0. So if 6 vectors are added, each of magnitude 10 unit, acting at an angle of 0 degree, 60 degree, 120 degree, 180 degree, 240 and 300, the resultant is of course 0. So we can add any number of vector. For example, again we solve a problem. For example, if a particle is given a displacement of 10 unit towards x-axis. A particle is given a displacement of 10 unit towards x-axis. 10 unit towards x-axis. So it is 10I. Again 20 unit towards, of course, north direction. 20 unit towards north, 10 unit towards east, and 20 root 2 unit towards southwest. East, 20 towards north. Now, what is the resultant displacement of the particle? What is the resultant displacement of the particle? Again, we can of course calculate the resultant displacement as the vector r1 is 10I plus 0j. This is the first vector. The second vector r2 is 0I plus 20j, and the third vector is r3 is 20 root 2 cos 225 plus 20 root 2 sin 225j. So now we can write R1 is equal to 10I plus 0j. R2 is 0I plus 20j, and R3 is, in the third coordinate both are negative, so it is 20I with a minus sign, and this is minus 20j. 20 root 2 cos 225 is 1 by root 2. So now this is cancelled, and the resultant vector r is minus 10I. So resultant is 10 unit towards west. And of course, thank you. In another, अगले क्लास में हम लोग फिर कुछ और बातचीत करेंगे। तो हमने आज वेक्टर को रिजॉल्व करने को बताया कि हम लोग कैसे, अगर कोई वेक्टर आर एक्स एक्सिस से थीटा एंगल बनाता है तो उसका एक्स कंपोनेंट आर कॉस थीटा होता है, वाई कंपोनेंट आर साइन थीटा. And if we want to add large number of vectors acting at a particular point, all the x components are added, and again all the y components are added, and we get the resultant of x and resultant of y component, and then rx square plus ry square will give you the resultant, and the resultant makes an angle theta, and the theta is of course ry by rx. So thank you and best of luck.